Okay, so today I want to talk about the section 10.2, the calculus with parametric curves. It's like outline. I want to talk about how can you find the slope of the tangent line to a parametric curve. How can you check if a parametric curve is concave up or down? I want to give some examples. Here, the parametric curve is given. You can choose the points here, is right? You can draw tangent line. So point here, we have vertical tangent line. Point here, so we have a horizontal tangent line. We have these kind of things. So how can you find slope tangent line? So let me see. This is exactly dy over dx. This is like x-axis. This is y-axis, or is dy over dx. The slope horizontal tangent line is 0. The dy over dx equal to 0. Slope the vertical tangent line is undefined. The dy over dx is undefined. How to check if the curve is concave up or down? We can use second derivative. d square of y over dx square. We can check this kind of things. The first derivative and tangents. How can you find? The next one. X equals f of t, y equal to g of t is given. You can change it to the y equals capital F of x. This is possible. I can just show this kind of things in section 10.1. My previous lecture, so you can define this kind of things in section 10.1. The next substitute x equals f of t, y equal to g of t into y equals f of x. So we have it. What does it mean? F of t is going to here, the f of t. The g of t is here, exactly g of t. The next, differentiate the both sides of g of t equals capital F of little f of t with respect to t. Like this. So what's that? Here, g prime of t. So in this case, f is outer function. The little f is inner function. You can use chain rule. The capital F prime of inner function, little f of t, times little f prime of t. The next, divide the both sides by f prime of t, like this. What happens? Crossed out. The capital F prime of little f of t is this one. Here, so we have it. Next, you can change the next one. The capital F prime is exactly same to y prime. What's like y prime? Same to dy over dx. You can replace this one by dy over dx. G prime of t is here. G prime of t is this y prime. Variable t, we can write dy over dt. This one. What's like f prime of t? F prime of t is this one, x prime. T is a variable, x is a function. You can write dx over dt. So we have this kind of things. So the curve has horizontal tangent line. What's that? The dy over dt, g prime of t equal to 0. Because curve has a horizontal tangent line, what does it mean? The dy over dx equal to 0. So exactly only top one equal to 0, but bottom one is non-zero. The 0 of non-zero is 0. So like this. Curve has a vertical tangent line, the if, so bottom one equal to 0, top one is non-zero. Why? Curve has vertical tangent line. What does it mean? dy over dx is undefined. So what kind of things? dy over dt is non-zero. dx over dt is 0. Non-zero of 0 form is undefined. Undefined, this is the whole idea for finding vertical tangent line. Then let's find one more. How can you find dy over dx? The dy over dx is exactly the slope tangent line, the dy over dt over dx over dt, the same to G prime of t over F prime of t. The G of t is this one, F of t is here. This is like a whole idea. Second derivative and concavity. X equals F of t, Y equal to G of t. So what's dy of dx? The dy of dt over dx of dt exactly same to G prime of t over F prime of t. It's like previous like a slide. So d square y dx square is, what's that? Same to this form, d over dx, dy over dx. So let me see. So what's that? What's it like this relation? This relation is d over dxy equals this one, d over dty over dx over dt. So like this. So what happens? What's that? What is this one? You can plug dy over dx into y. You plug into here, plug into here. That's it. That's the whole idea. So we have d over dt of dy over dx over, keep this one, dx over dt. This is dt, dx over dt. So that's it. This is exactly second derivative. What's it like dy over dt? dy over dt is this form. We can plug into here exactly g prime of t over f prime of t prime over dx of dt is same to f prime of t. This is like a second derivative. This is second derivative. Don't like this. This one, don't like this. The curve is concave upward. What does it mean? Second derivative, positive. The curve is concave down. The second derivative is less than 0. So we have the two things for the concavities. Here, this is like a problem. The curve C is defined by the parametric equation. X equals cosine of t, y equals sine of t. The t is between 0 and 2 pi. The first question, find an equation of the tangent line to the curve C at t equals 5, 6. Find the point on C where the tangent is horizontal or vertical. Next, determine where the curve is concave upward or downward. We have 3 problems. So how can you find equation of a tangent line? The equation of a tangent line is like this. The first, you need to find this one here. So I want to give the one example here. So one parametric curve is given, this one. We have choose one point. So this is t equals like p. So what does it mean? So this point is, x value is, here. So we have this curve is, the x equal f of t. The y equal g of t. Like this one. So we can plug p into here. So x component is f of p. What's it like y component? The y component is g of p. You can draw tangent line. The tangent line. What's the slope? The slope is dy over dx at the t equals p. T equals p. So what's it like equation of a tangent line? Equation of tangent line is, I want to use point slope form. Y minus the y component is g of p. So we have g of p equals find slope of tangent line at t equals p, dy over dx at t equals p times x minus f of p. F of p is like x component. That's it. This is equation of tangent line. It's good? So, how can you find the answer of first question? The first, find dy over dx. What's like dy over dx? We can use formula. So exactly here dx of dt. dy of dt over dx over dt. What's like dy over dt? dy over dt is y prime. Y is a sine function. Exactly sine prime. Over dx over dt is x prime. X is cosine of t prime. So what is the sine of t? Could you run your answer on the chatting board? What is the sine of t? Sine of t is, so could you run your answer? Yep. Okay, good. We have a cosine of t. Yeah, thank you, all of guys. Was it like a cosine of t? Could you run your answer on the chatting board? Was it cosine of t? Okay, good. We have negative sine of t. The next, you can find dy over dx at t equals p. What's p? This p is pi over 6. So you can find the slope tangent line is dy over dx at the t equals pi over 6. You can plug pi over 6 into t, cosine pi over 6 over negative sine pi over 6. Like this. So what is cosine pi over 6? Do you know what is cosine pi over 6? Cosine pi over 6 is, yeah, right? Yeah, square root of 3 over 2. Square root of 3 over 2. The keep negative. Sine pi over 6 is, do you know sine pi over 6? Yep. Sine pi over 6 is, yep. Okay, good. 1 over 2 and simplify. Numerator times reciprocal of denominator, the negative 2 over 1. 2 is crossed out. Answer is negative root 3. This is slope of tangent line. The next, you can find the x component of a point, y component of a point. What's x component? You can plug t equals pi over 6 into x here. So we have x equals cosine pi over 6. Cosine pi over 6 is root 3 over 2. You can find t equals pi over 6 into y. The y is here. Sine of t. Sine of pi over 6. Sine of pi over 6 is 1/2. So we have 1 point. What's the point? The point is the x component root 3 over 2. Y component 1 over 2. The next, find equation of a tangent line. The equation of the tangent line is tangent line is y minus y component of the point equals slope negative root 3 times x minus x component root 3 over 2. Like this. Next, expand and simplify. This is same to y minus 1 over 2 equals distribute negative root 3, negative root 3x. The negative root 3 times negative root 3 is positive 3 over 2. Next, you add 1 over 2 to the both sides. So what's it like equation of tangent line? Y equals, because 1/2 is cancelled, the minus root 3 of x. The 3 over 2 plus 1 over 2 is plus 2. So that's it. This is answer of first question. Answer of first question. This is the idea. Is A. Here, like this. Yeah, we have it. This one. So we have this kind of things. Second one, find the point on C where the tangent is horizontal or vertical. We are going back to slope. What's the slope? Here. The slope dy over dx is the cosine of t over negative sine of t. So we have it. What's it like a horizontal tangent line? dy over dx equal to 0. We have a horizontal tangent line. dy over dx is undefined. We have a vertical tangent line. So we can use this idea, this note. So here, so what's that? First one, horizontal tangent line. Horizontal tangent line. This is the first one. What's like the first one? Here, only dy over dt, g prime of t equal to 0. Only top one equal to 0. Top one is cosine of t equal to 0. Cosine of t equal to 0. The bottom one is non-zero. This is like a 0. This is like a non-zero. Bottom is like a non-zero. So we have negative sine of t is not equal to 0. The negative sine of t is not equal to 0. So what's it like a t? You can just solve this one first. Cosine of t equal to 0. What's t? The t is between 0 and the 2 pi. This is like a domain. Could you run your answer on the chatting board? The cosine of t equal to 0. What is t? The pi of 2 is right. Pi of 2. That's it. Only 1 point. Pi of 2. Only 1 point. The 3 pi of 2 is right. 3 pi of 2. So yes, we have 2 points here. What's the graph of cosine? The graph of cosine is like this from 0 to pi of 2, like this. So this point is, this is cosine of t, pi of 2. This point is 3 pi of 2. We have 2 points, the pi of 2 and 3 pi of 2. You can plug pi of 2 into t. The sine of pi of t is 1, not equal to 0. You can plug 3 pi of into t. Sine 3 pi of 2 is minus 1. Minus 1 times minus 1 is positive 1. 1 is not equal to 0. Yes, we have 2 things. This is like not a final. You can find exact point on C. What does it mean? So you can plug t equals pi of 2 into x and y. You can plug into x and y. So what is x? X is cosine pi of 2. Cosine pi of 2 is 0. You plug y. Y is sine pi of 2. Sine pi of 2. Sine pi of 2 is 1. So what's the point? Point is 0 and 1. So like this. So t equals 3 pi of 2. You plug into x, y again. Cosine 3 pi of 2. Cosine 3 pi of 2. Cosine 3 pi of 2 is like 0. So here is right, and 0. The y is sine 3 pi of 2. Do you know what is sine 3 pi of 2? So could you write your answer on the chatting board? What is sine 3 pi of 2? Answer is, okay, it's good, minus 1. So we have another point, 0 and minus 1. So what does it mean? We have 2 points. So we have horizontal tangent line. Horizontal tangent line at 2 points, 0, 1, and 0 and minus 1. So like this. This is the first one. You think about second one. Second one is the curve has vertical tangent line. What's that? Bottom one equal to 0. Bottom one is negative sine of t equal to 0. Another one, top one is non-zero. Top one is cosine t is non-zero. You can just solve this one first. Sine of t equal to 0. What's t? So could you write your answer on the chatting board, please? The pi and 2 pi, only pi, 0 pi, 2 pi, 0 pi, 2 pi, yes, 0 pi, 2 pi. So we have here, was it like a sine function? Sine function is, graph is like this. This is sine of t, angle 0, angle pi, angle 2 pi. We have 0, pi, 2 pi. So like this. So t equals 0. You can plug into x and y. Find x component, y component. X is cosine of 0. Cosine of 0 is 1. The y is sine of 0. Sine of 0 is 0. 1.10. So like this. Next, you plug t equals pi of 2. Sorry, pi. The angle pi into here. Cosine of pi, sine of pi. So we have x equals cosine of pi. The cosine of pi is here. Pi. Answer is negative 1. Y equals sine of pi. Answer is 0. So what's that? Exactly negative 1, 0. T equals 2 pi. Equal to 2 pi. What is x? X is cosine 2 pi. Cosine 2 pi is 1. Y equals sine of 2 pi. Sine of 2 pi is 0. So we have 0.10. So how many points do we have? Only 2 points. 1, 0, 1, 0 with the same things. So answer is we have vertical tangent line. Vertical tangent line at 1, 0 and minus 1, 0. So like this. So 1, 0 and minus 1, 0. We have 2 points. This makes sense? This makes sense. So because I'm going to sketch the graph here, you can draw sketch the graph of x equals cosine of t, y equals sine of t. You can see my lecture note or my lecture video section, like the 10.1, my previous lecture, I solve this problem. I can draw graph of cosine, x equals cosine, y equals sine. Graph is exactly here, circle, unicircle. This is 1, 0. This is minus 1, 0. This one is 0, 1. This one is 0, minus 1. What happened at this point? This point is like move along the unicircle in the counterclockwise direction. Was like this value? T equals 0 and 2 pi. We have it. Here, top one is 0 equals, t equals pi over 2. This point, the t equals pi. This point, 0 and minus 1, t equals 3 pi over 2. 3 pi over 2. So what happens? We have two horizontal tangent line at 0, 1, 0, minus 1. Yes, we have it. 0, 1, 0, minus 1. We have two vertical tangent line at angle 0, pi, 2 pi, right? 0, pi, 2 pi. Yes, 0, pi, 2 pi. 1, 0, minus 1, 0, 1, 0. Yes, this is true. So by using the graph, this is like idea. Like this. The next one. Determine whether the curve is concave upward or downward. We can use this rule. So we already have this one. X equals cosine of t, y equals sine of t. dy of dx is cosine t over negative sine of t, exactly same to negative cotangent of t. What's concave of d square y over dx squared is positive. Concave downward, the second derivative is less than 0. How can you find the second derivative? You can use this rule. This is like from previous one. The d square y over dx square. What is it? dy over dx? dy over dx is negative cotangent. Exactly negative cotangent prime. Over. F prime of t is here. F of t is the dx of dt. The dx of dt is this is one x prime here. Cosine of t prime. So do you know what is a negative cotangent prime? Could you run your answer on the chatting board? What is a negative cotangent prime? The negative cotangent prime is, do you know answer? Could you run your answer on the chatting board, please? What is like a negative cotangent prime? Yeah, is it right? The cotangent prime is negative cosecant square. The minus 1 times minus 1 is change positive. Cosecant square of t. Over cosine t prime is negative sine of t. So like this. So next, simplify. The minus cosine square of t is like this. You can change it. Keep negative. The cosecant of t is 1 over sine. 1 over sine square of t. Over sine of t. Same to negative 1 over sine square of t times the reciprocal of denominator 1 over sine of t. So we have negative 1 over sine cube. So like this. What's the concave of? So second derivative is positive. So when do you have this one? Only here. So this is negative. Automatically, bottom one is also negative. What's like bottom one is also negative? Sine cube t is less than 0. Automatically, the 3 is like odd power. Inside one, sine of t is less than 0. We have concave of. Sine of t is less than 0. What's that? You can draw graph of sine function. The 0, pi, 2 pi. What's that? Sine function is negative only here. The t value is between pi and 2 pi. Like this, concave downward. Concave, the downward. So second derivative is less than 0. The top one is negative. Automatically, bottom one equal to positive. Whole thing is negative. So we have sine cube t is greater than 0. Automatically, inside one, sine of t is greater than 0. Same. You can draw graph of sine like this. It's like 0, pi, 2 pi. The which one is positive? Only 0 to pi. This is reason. So we have t is between 0 and pi. Like this. Like this. So yeah, this is like a whole idea for solving this problem. The next tip, we are going to second problem. A curve C is defined by the parametric equation x equals to t squared, y equals to t cubed minus 3t to show that C has two tangents at the point 3, 0. Find their equations. Find the point on C where the tangent is horizontal or vertical. C, determine where the curve is concave upward or downward. The last one, sketch the curve. Sketch the curve. So let me see. What do you think? This is possible? The curve C has two tangent lines at only one point. This is a possible one. What do you think? The parametric curve has two tangent lines at one point. This is possible? Yes or no? What do you think? The question, write your answer on the chatting board. What is your answer? The parametric curve has two tangent lines. Jump discontinuity? No. This is like a jump discontinuity. We don't have a tangent line. So the graph is like this. Graph is like a jump. This one. So here, we don't have any tangent line. We don't have any tangent line. So we don't have it. So in this case, what's like assumption? The parametric curve is continuous. Continuous, only continuous. Is it possible? Yes or no? What do you think? Yes or no? This is yes. Was it like a parametric curve? You can draw the parametric curve, curves like this. This is possible. Move here, here, here. What happens? Move to this way. From here, this is a tangent line. So move more, 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 and going back, this is tangent line. We have two tangent lines possible. The three tangent lines possible? Yes. Graphs like this. Move here and down and more. So like this. That's right. So we have here one tangent line. Going back, this one. Going back, this one. We have three tangents possible. That's right. So anyway, this is possible. So how can you find the slow tangent line? You can use dy of dx equals dy of dt over dx of dt, g prime of t over f prime of t. This is the idea. What's that? Here, the dy of dt, the y is this function, t cubed negative 3t prime. Over f prime is x prime, t square prime. We have 3t square, negative 3 over 2t. This is dy of dx, so like this. The next tip, we have this one. So points like 3, 0. Points like 3, 0. You can find corresponding t value. The 3 is like x value, 0 is y value. How can you find the t value? You can plug 3 into here. So 3 equals t squared. You plug 0 into here. The 0 equals t cubed, negative 3t. What's t? The t is the root 3 or minus root 3. This one, you can factor out t times t squared, negative 3 equal to 0. So we have t equal to 0, or the t squared minus 3 equal to 0. Here, t equal to 0, t squared equal to 3, take square root, what's t? T is 0. The root 3, this one, or minus root 3. So what's like t values? You can find the common things. We have top and the bottom one, we have this kind of answers. Common thing is root 3 and minus root 3. So not 0. 0 is only bottom one. Top one doesn't have 0. We have 2 points. Is what? The root 3 and minus root 3. So like this. What does it mean? Graph is like this. going up, up, down. Anyway, always this is like point P, the 3, 0, like this. So we know a little bit shape of the graph. This is possible. We can assume like this. Here, find point. Yep, common things, t and the minus root 3 and the root 3. The next, the equational tangent line, we have it. So this is like equational tangent line. I write before this equational tangent line, the exactly same to the previous one. So the dy of dx is 3t squared minus 3 over 2t from the previous calculation. So next, you can define this one. How can you find? The t is negative root 3. You plug negative root 3 into here. You can find dy over dx first. What's like dy over dx? dy over dx at the t equals minus root 3. You can plug minus root 3 into t. So here we have 3 times minus root 3 squared, the negative 3 over 2 times minus root 3. The minus root 3 squared is 3. 3 times 3 is 9. 9 minus 3 over the negative 2 times root 3. So we have 6 over 2 times root 3. 2 is crossed out, only 3. The 3 over root 3. I want to rationalize the denominator. So multiply top and bottom by root 3. 3 times root 3. The root 3 times root 3 is 3. Answer is root 3. Keep minus, I think. Sorry, keep negative. Keep negative. The minus root 3. So we have it. This is like a slope. You need to find the x component to y component here. How can you find the x component? F of p. You can plug the minus root 3 into x. So you can find x component. The like t equals minus root 3. You plug into x. X is here. The root 3 squared. Minus root 3 squared. Only 3. You plug t equals minus root 3 into y. Y is here. So we have minus root 3 cubed. Minus 3 times root 3. 3 times minus root 3. The minus root 3 cubed is negative 3 times root 3. The minus 1 times minus 1 is positive 3 root 3. Answer is 0. So was it like one equation? So we have 1 point. What's the point on the curve? This point is here. X component 3. Y component 0. So we have, you don't need to find this kind of things because point is given. Sorry, you don't need it. Exactly same. You don't need to find this point. Point is given. So only find slope. So what's it like equation of a tangent line? Y minus the y component 0. So slope is minus root 3. X minus x component 3. Like this. So we have y equals minus root 3, x minus 3. This is one equation of a tangent line at t equals minus root 3. T equals minus root 3. The next, what's the equation of a tangent line at t equals root 3? You can use same procedure. I can just show a little bit more here. You can write here, it's better. You can do root 3, same. You can find dy over dx at t equals root 3. You plug root 3 into here. T value, 3 times root 3 squared minus 3 over 2 times root 3. The root 3 square is 3. 3 times 3 is 9. 9 minus 3 over 2 root 3. Same to the 6 over 2 times the square root of 3. 2 is crossed out. Only 3. We have 3 over root 3. So multiply top one and bottom by root 3. So this is same to 3 root 3 over 3. 3 is crossed out. So root 3. This is slope. So point is given. 3, 0, same things. What's like equation? Equation is y minus the y component of point 0. The slope is root 3. Slope is root 3. X minus y component 3. So we have one more equation. Y equals root 3 times x minus 3. So we have second equation of a tangent line. So far we have 2 tangent lines, right? This one and this one. We have different 2 tangent lines. So in this case, at what's t? T equals positive root 3. What this one? At the t equals negative root 3. So we have the 2 tangent lines. This is idea for solving problem A. So like this. This one, so we have it. Next tip, so find the point on C where the tangent line is horizontal and vertical. So we can use this idea. So this is like my previous calculation. So we have it. What the curve has a horizontal tangent line? G prime of t equal to 0, f prime of t is not equal to 0. This is like the first one. This is like the second one. What's like the first one? Only the dy of dt equal to 0. Exactly, top one equal to 0. We have 3t squared minus 3 equal to 0. One more, dx of dt is not equal to 0. What's that? Bottom is non-zero. 2t is non-zero. So we can solve this one. So what's that? So 3t squared equal to 3. Add 3. Divided by 3. What is t? So could you write your answer on the chatting board? What is t? The t squared equals 1. What is t? So could you write your answer on the chatting board? What is t? The t squared equals 1. What is t? Just 1? The 1 and minus 1? So what do you think? 1 and minus 1? Is it right? Yes. T squared equals 1. T is plus or minus 1. We have 2 points. You can plug t equals 1 into here. X and y, you plug into here. So x is the 1 square is 1. What's y? You can plug 1 into here, 1 cube. Negative 3 times 1. 1 minus 3 is negative 2. So what's the point? Point is 1 and negative 2. Here, right? X is 1, y component minus 2. This point, the t equals minus 1. You plug into here. Is again, x equals minus 1 square is 1. So y is, you can plug minus 1 into t, so minus 1 cube, negative 3 times minus 1. So minus 1 cube is minus 1. The negative 3 times minus 1 is positive 3. We have only 2. We have another point. What's that? 1 and 2. Like this, right? So what's the answer? We have horizontal tangent. Yup, you're right. 1 and minus 2. One more. What's that? 1 and 2. We have 2 points. 1 and minus 1 and 1 and 2. So in this case, what's the t values? t value is 1. But this one, the t value is minus 1. We have this result. The next vertical tangent line. So let me see which one equal to 0. The 3t square minus 3 equal to 0 or 2t equal to 0. top one equal to 0 or bottom one equal to 0. So which one equal to 0 for finding vertical tangent line? Could you write your answer? Yeah, bottom one equal to 0. You're right. Here, the dx of dt equal to 0. Only bottom one. The 2t equal to 0. But top one is non-zero. dy of dt is like top one. The 3, the t square minus 3 is not equal to 0. Only solve this one. What's t? t is 0. Only plug 0 into x and y here. Plug 0, plug 0, plug 0. X is 0 square, 0. Y is 0 cube, negative 3 times 0 is also 0. So what does it mean? So we have point 0, 0, right? Point x component 0, y component 0. What does it mean? We have vertical tangent line. Vertical tangent line at what's the point? 0, 0. Point 0, 0. So in this case, what's the t value? The t value is also 0. So this is the answer of second question. This is answer of second question. So we have it like this. This one. The third one. So determine where the curve is concave up, concave down. So we already know that the first derivative here, the dy of dx is the 3t square minus 3 over 2t. So how can you do that? Here, factor out 3. You can change it. 3 over 2 times here, t square minus 1 over t. The next is 3 over 2, the split. The t square over t minus 1 over t. Same to 3 over 2. The t is crossed out, only t minus 1 over t. We have this form. This form. So what's it concave up, concave down? So you can use second derivative. Second derivative positive, concave up. Second derivative is less than 0, concave down. So here, you can use a formula. So what's that? It's the same to the, what's that? dy of dx is this one. You can plug into here. So what does it mean? Exactly the 3 over 2 times t minus 1 over t prime. 이렇게 답은 over. The f prime is dx over dt. dx is t square, only t square prime. T square prime. So what's that? Keep 3 over 2 times t prime. T prime is 1. What's it? 1 over t prime here? 1 over t prime. You can use quotient rule. The 1 prime times t minus 1 times t prime over bottom one squared. So 1 prime is 0. The t prime is 1. The minus 1 times 1 is negative 1 over t squared. We have to keep negative sign, the negative minus 1 over t squared over. The t squared prime is only 2t. So we have this result, 3 over 2. This one is change positive, 1 over 1 plus 1 over t squared over 2t. That's right. So like this. Next, simplify. So here, 3 over 2 over t combine. The 3 over 2 over 2 is the 3 over 2 times reciprocal denominator, 1 over 2, the 3 over 4. We have the remaining part. The next, you can multiply top and bottom by t square. Like this. Keep 3 over 4. Distribute t square to the 1 and 1 over t square. 1 times the t square is t square. The t square is crossed out, plus 1 over. T times t square is t cubed. So like this. So we have it. The next, concave up or down. How can check? Here. Concave upward, the second derivative positive. So what happens? The t squared is positive or equal to 0 and add top one is always positive. So this is like whole thing is positive depending on bottom one. Bottom one is also positive. We have t cube is positive. Automatically t is positive. We have concave up. Concave up is like this. Concave down. The second derivative is less than 0. So what's the top one? T squared plus 1 is, yes, always positive. What's the bottom one? Is negative. What does it mean? The t cube is less than 0. Take a cube root, t is less than 0. T is less than 0, graph is concave down. So like this. So it's good. So this is answer of third question. The last one. How can you sketch the graph? So graph is, you can use the all information from the A, B, C. The A, B, C, here. We have two tangent lines at 3, 0, so like this. So like answer of first question. Y equals, this is like A. Answer of first question. Y equals minus root 3, x minus 3 at t equals minus root 3. Y equals root 3, x minus 3 at t equals root 3. Tangent line is horizontal at 1, 2. In this case, t is minus 1. The 1 and minus 2, t is 1. This is like B. The tangent line is vertical at 0, 0. In this case, t is 0. Exactly answer of B. The last one, concave up for t is greater than 0. Concave down for t is less than 0. So we have this information. I can sketch the graph. I can use this idea. The first one, you can draw like x-axis, y-axis. You can draw x-axis, y-axis here. Next, you can plot here 3, 0. This point. So what happens? T equals minus root 3. We have this tangent line. The minus root 3, x minus 3. The graph is like this one. Decreasing tangent line, so like this. So we have this tangent line. What's that? In this case, t equals minus root 3. Another one here. The y equals root 3 times x minus 3. We have another tangent line. This one. This is increasing things. What's t? In this case, t is the root 3. We have this one, this tangent line. Here, two tangent lines. The next one, 1, 2. 1, 2. This point, we have horizontal tangent line. We have horizontal tangent line. Here, t is what? Minus 1. The 1 and minus 2. 1 and minus 2. This point, we have another horizontal tangent line. the t is positive 1. We have vertical tangent line at 0, 0. Here we have vertical tangent line. Vertical tangent line, in this case, t equal to 0. That's right. So what's it like direction? Here, t is minus 3, this point. T equals to minus 1, t equal to 0, t is 1, t is positive 3, yes, right? Move to the like this way, the counterclockwise direction. So one more. What's the concave up? T is greater than 1, concave up. Concave up here. 0, 1, 3, concave up. The t is less than 0, concave down. The minus root 3, minus 1, 0. In this case, concave down. You can connect these 2 points, not 2 points, 1, 2, 3, 4. These are 4 points by using concavity and use the vertical tangent line, the horizontal tangent line. We have 2 tangent lines. What's it like a graphic? Graph is like this. The graph is like this one here. Passing through here, like this, like only touch the tangent line, the concave up, going up like this, and touch. We have horizontal tangent line and concave up, concave down, and vertical tangent line. So move to the like this one, and here concavity change that one, concave up, concavity, the change it, and this is a horizontal tangent line, and going this way. Same, this is, we have this tangent line, approach this one, and tangent line, like this, right? So move to the like this. This is the whole idea. Graph is like this. Yeah, so this is like all for today lecture. I can talk about the 2 kind of things. So the first derivative and the second derivative, the first derivative and second derivative from the parametric equations, like a key parts. Okay, this is all for today lecture. So if you have any question, you can write your questions on the chatting board. So if you don't have any more question, you can leave live session. So thank you for attending my class today. I really appreciate about that. So thank you. I'm waiting. Okay, you're welcome. So you're welcome. So you're welcome, all of guys. Yeah, thank you. You're welcome. Yeah, I'm just waiting. The any question, you can write your question on the chatting board. So if you don't have any more question, you can leave a live session.